So imagine for a second that you're an engineer, right?
Right.
And you are tasked with designing this incredibly efficient, high-speed pollinating machine.
Oh, wow. Okay, setting the bar high.
Right. You'd want a lightweight chassis, super rapid mobility, and, this highly specialized extraction tool just designed to pull every last drop of liquid fuel out of a specific flower.
And you'd have to do it without wasting any internal power, I assume.
Exactly, without wasting power.
Well, I mean, you're basically describing a machine built entirely for a single, uncompromising environment.
Yeah.
Like, the moment you take it out of that specific zone, it just breaks down completely. But inside its environment, it totally outcompetes everything else.
Yeah, but nature actually already beat us to that design.
Yeah.
Today, we're going on a deep dive into a creature that operates exactly like that. A tiny, feathered pollinating machine.
The Cape Sugarbird.
The Cape Sugarbird is this iconic species completely endemic to the Fynbos biome in South Africa. And it's actually one of only 2 sugarbird species on the entire planet, which is wild.
It really is.
So to figure out how this bird survives in such a volatile environment, we're cross-referencing a pretty diverse stack of sources today. We've got regional tourism guides for the garden route, some really detailed ornithological profiles.
Yep, the heavy science stuff.
Yeah, exactly. Plus a master's thesis tracking Fynbos snake communities and this really recent scientific paper analyzing urban ecology in Cape Town.
Because understanding the Cape Sugarbird, I mean, it really requires understanding the Fynbos itself. You just cannot separate the two.
No, you really can't.
Before we even look at the environmental pressures they face, we kind of have to look at the physical tools they use to navigate them.
Right, let's start with the bird itself.
Mm-hmm.
The Sugarbird, which is its Afrikaans name. And when you first glance at them, honestly, the upper body just seems like a standard drab brown.
Yeah, a bit underwhelming at first glance.
Right, with some dark streaking.
Yeah.
But the moment the bird actually takes flight, that whole camouflage breaks. Underneath the tail, there's this striking bright yellow patch.
Oh, it's beautiful.
And they have this gray-brown crown, a really harsh black meller stripe cutting across the cheek. And that's bordered by a crisp white moustachial stripe and a white chin.
But the thing you notice most is the bill.
Yes. The bill is long, it's black, and it's distinctively decurved. It looks almost like a small scythe.
Which is wild, but that bill is really just the protective housing for the actual engineering marvel, right? The tongue.
Right.
Because it's not a hollow straw. You know, people think they just suck up nectar, but sucking requires a lot of muscular energy.
And when you're visiting hundreds of flowers a day, you definitely cannot afford to waste energy on just extracting the food.
Exactly. So instead of a straw, the tip of the tongue is frayed. It looks like this microscopic paintbrush.
The sources actually describe it as being perfectly adapted for capillary action, right?
Yeah. So when that brush tip touches the nectar pool, which is way deep inside a Portia flower surface, tension literally pulls the liquid up the microscopic channels between those bristles.
Wow. So it's just physics doing the heavy lifting.
Yeah. Completely. The fluid dynamics of the nectar itself do the work. It defies gravity, creeping up the tongue automatically. The bird just dips its tongue, lets physics take over, and retracts it.
Okay, let's unpack this. Because I look at a feeding mechanism that's specialized like a beak and tongue, custom evolved for the deep chalice of one specific plant, the protea.
Mm-hmm.
And I instantly see a massive vulnerability.
You mean being too specialized?
Yeah. If you evolve to rely entirely on the mechanical structure of one plant, aren't you just tying your hands? Like if a disease wipes out the proteas or a bad fire destroys your local supply, you have literally zero backup plan.
It's a fair point. And what's fascinating here is that in a lot of evolutionary contexts, that kind of hyperspecialization is a total dead end.
Right.
But in the Cape Floristic Kingdom, it operates as this incredible mutualistic stronghold. You see, the protea bushes produce this really heavily diluted, high-volume nectar specifically to attract birds.
Oh, rather than insects?
Right, because birds can carry the plant's heavy pollen over much, much larger distances. So the plant effectively guarantees this reliable food source, and the bird provides a reliable long-distance courier service.
And that courier service basically dictates their entire lifestyle. I mean, because they're so tied to this specific fuel source, their zip code literally changes based on whatever is blooming at the time.
They are constantly chasing the bloom.
Yeah, the ornithological profiles in our stack classify them as altitudinal migrants. The data shows them moving anywhere from 27 to 44 kilometers and sometimes even further.
Just following the buffet line.
Exactly. As the seasonal temperatures shift, the blooming proteas move up and down the mountain slopes, and the sugarbirds just pack up and follow them.
And they need a lot of energy to do that. Nectar is amazing for fast-burning carbohydrates, which fuels that constant flying.
But nectar has basically zero protein.
Right. And if you're constantly flying, defending territory, rebuilding muscle carbs alone are just going to lead to malnutrition.
Which brings us to the bug hunting. They actually hawk insects midair.
It's so cool to watch.
The data lists them snatching beetles, bees, flies, ants, wasps, and spiders just right out of the sky. So they use that high-octane sugar to fuel the aggressive flight mechanics they need to hunt protein.
And aggressive is the word. Their flight patterns are so intense.
They're really strong flyers. But the sources mention that when they approach a perch, they don't just, glide in and hit the brakes like a normal bird.
No, they do this crazy maneuver.
The unbraked upward flip jump.
That's the one.
They fly in at full speed and then just snap upward at the very last second, using gravity to kill all their momentum so they drop right onto the branch.
Which is genius, right? Because they are landing on these flimsy, swaying protea branches. If they just slammed into them, they'd snap the plant.
Oh, that makes sense.
But it requires a staggering amount of agility, which is even more wild when you consider the massive anatomical handicap the males are dragging around.
Oh, the tail. We have to talk about the tail.
It's absurd.
The male Cape sugarbird has this shaggy dark brown tail that can reach up to 32 centimeters long. The female's tail is like half that length.
So the male's tail is basically twice the length of his entire body.
Yeah. And growing, maintaining, and just trying to fly with a tail that massive that demands a huge caloric output.
Huge. And that energy requirement is actually forcing a behavioral shift as their natural habitats shrink down.
Which we see heavily in that urban ecology paper about Cape Town. Cape sugarbirds are increasingly just moving right into city gardens, using native bird-pollinated plants, bird baths, and artificial sugar water feeders.
Which a lot of people have in their yards.
Right. But reading through this paper, I couldn't help but wonder about our role in this. Like, we put out a sugar feeder, and we assume we're being these great accidental conservationists by providing a little oasis.
And are we creating an ecological trap?
Exactly. If we give them this endless supply of easy sugar, do we completely disrupt that altitudinal migration they've relied on for thousands of years?
It's tough. That tension is really at the very center of urban wildlife management right now. Human encroachment is just systematically fracturing the continuous stretches of Fynbos they usually navigate.
Right, it's getting broken up into smaller and smaller patches.
And the data from Cape Town indicates that while, yes, these urban gardens provide a necessary lifeline, they do not function as true replacement habitats.
Because they can't breed there.
Exactly. A key finding in the paper is that a sugarbird's survival in the city is strictly limited by the garden's proximity to a natural habitat. They cannot sustain a population just on artificial feeders and fragmented garden patches.
So we're essentially providing temporary way stations.
Yeah.
But they still require massive, continuous vegetated areas for the most critical part of their life.
The breeding season.
Yeah, because they need the deep, native Fynbos for breeding, which requires an utterly exhausting amount of energy. I was looking at the timeline for this in the sources, and it feels completely counterintuitive.
You'd think spring, right?
Right. You assume they breed in the warm, resource-heavy months. But no, the Cape sugarbird breeds in the brutal cold of the South African winter, mostly from February to August.
And it all goes back to the protea.
Always the protea.
Always. Proteas are winter bloomers. They evolved to flower during the wet season in the Cape to basically minimize competition from insects, which just aren't active in the cold.
Oh, so that ensures the birds become the primary pollinators.
Exactly. So the sugarbirds have to endure these harsh winter conditions because that is the only window when their primary fuel is abundant enough to actually support reproduction.
And the behavioral displays during this freezing winter window are so aggressive. The males stake out the biggest, most prominent flowering protea bushes and take to the air to defend them.
Flying like 10 meters high.
Yeah, 10 meters up in these undulating wave-like patterns. And while they're flying, that 32-centimeter tail is just whipping up and down.
Making that loud clacking noise.
Yeah. Plus this mechanical wing noise that sounds like a rapid furt, furt, furt. And on top of all that, a grating vocal song that the sources describe as K-swip chirring, ka-swip chick, chick, chick.
It's literally a full sensory broadcast to every single bird in the valley.
And the ornithological studies confirm that the physical metrics of this display totally determine reproductive success. Right?
Yeah.
Yeah.
Males with the longest tails, the longest wings, and the greatest body mass consistently secure the most resource-rich territories.
And the most mates. Here's where it gets really interesting to me. That 32-centimeter tail operates under what they call the handicap principle.
Oh, I love this concept.
It's like owning a highly temperamental vintage sports car. It is completely impractical for daily survival and incredibly expensive to maintain, but it proves to the females that you have the excess resources required to run it.
That's a great way to put it.
The male is basically demonstrating, look, my genetics are so superior that I can survive this freezing winter, outmaneuver predators, and hunt insects midair, all while dragging this massive aerodynamic parachute behind me.
Because it's an honest biological signal. A sick or genetically inferior bird just cannot fake the energy reserves required to grow and fly with a tail that long.
Right. But the paradox there is that the very trait proving his fitness makes him incredibly conspicuous to predators.
He's practically a neon sign in the Fynbos.
Meanwhile, the female is engaged in intense physical labor down on the ground. She builds the nest entirely alone over like 5 to 10 days.
Just bending green stems to form the foundation.
Yeah, weaving this untidy cup-shaped structure out of dead leaves, dry grass, rootlets, and literally binding it together with spider webs.
This is incredible.
And then she lines the inner cup with this soft brown down taken right from the center of the protea flowers, which gives the eggs critical thermal insulation against those freezing winter nights.
And she hides this nest deep within the central foliage of a bush, usually only about, a quarter of a meter to maybe 2.5 meters off the ground?
Yeah, really low. She lays 1 or 2 buff-colored eggs with brown markings and just defends them fiercely.
If a threat approaches that low-hanging nest, she has a whole routine.
The distraction display. She will actually feign a broken wing, fluttering helplessly along the ground to convince the predator that she's an easy meal.
Deliberately luring them away from the eggs?
Yeah, putting her own life in immediate jeopardy. And that deception is tested all the time, because the Fynbos ecosystem has predators attacking from literally every vertical level.
It's a tough neighborhood.
From the sky, the sources point to the white-necked raven as a primary predator of adult sugarbirds. Ground-level threats include the small gray mongoose, which will just systematically raid nests.
And other birds, too, like shrikes and boo-boos, they target the chicks and eggs.
But the threat that really stood out to me comes from that master's thesis on Fynbos snake communities.
Oh, the snakes. Yeah. Reptiles are uniquely equipped to exploit those low-hanging nests. Their morphology just lets them navigate the dense inner branches of the protea bushes, where birds of prey and mammals really struggle to reach.
The thesis identifies the olive house snake, but it highlights a much larger threat too, the mole snake.
That's a big one.
It's massive, this powerful non-venomous constrictor. And while they primarily hunt rodents underground, the tracking data shows they regularly climb up into the shrubs to eat birds, frogs, and eggs.
A sugarbird nest sitting a meter off the ground is a prime target for a heavy constrictor.
And the irony here is just stark. The bird's food, its nesting material, and its entire breeding cycle depend on the protea bush. But that exact same bush serves as a vertical hunting ground for massive snakes.
Yeah.
It's like living your whole life inside a beautiful but very deadly grocery store.
Well, if we connect this to the bigger picture, that dynamic is actually a primary indicator of a really healthy, functioning environment.
Really. The snakes eating them is a good sign.
Counterintuitive, I know. But when an ecosystem can support large, apex-level predators like heavy constrictors, it signifies that the trophic levels are completely intact.
Ah, meaning the underlying food web is robust enough to carry the heavyweights at the top.
Exactly that. A habitat can only sustain a population of bird-eating mole snakes if there is a thriving foundation of plants and prey beneath them. So natural predation from snakes and mongooses, that's a sign of ecological balance. The real existential threats are the ones altering the landscape itself.
Right, like agricultural expansion in the coastal lowland Fynbos, systematically clearing their native range.
Yes, but the more insidious threat involves the disruption of the natural fire regimes.
Because the Fynbos is fundamentally a fire-adapted ecosystem, right?
It is. Many of the native plants are serotinous, meaning they literally require the heat and smoke of a fire to melt the resin sealing their seed cones.
So they can release the seeds and regenerate.
Exactly. Without periodic fires, the Fynbos just dies.
But the introduction of invasive alien plants has completely warped that natural cycle. The source is focused specifically on Australian species, like Acacia cyclops and Acacia solenia, which ironically were imported in the 1800s just to stabilize shifting sand dunes.
Right. And they stabilize the dunes, but they also produce a staggering amount of woody biomass, way more than the native Fynbos shrubs do.
So when a fire hits...
When a fire sweeps through an area heavily invaded by acacias, the excess fuel causes it to burn exponentially hotter than it naturally would.
Oh, man.
Yeah, that intense, unnatural heat doesn't just melt the resins to release seeds. It completely incinerates the seed bank buried in the soil. It permanently alters the nutrient cycling, making it impossible for the native Fynbos to recover.
And if the Fynbos doesn't recover, neither do the nesting sites.
Exactly.
There's also a direct conflict with human agriculture mentioned in the sources. The data highlights instances where commercial protea farmers have actively poisoned Cape sugarbirds to protect their flower crops, believing the birds damage the blooms.
Which is an ongoing point of tension.
It is. And our goal here is just to report what's in the sources, so we're obviously not taking sides on agricultural policy. But it is worth noting that the scientific and ornithological sources we're looking at do challenge that practice.
Right. The field studies in our stack argue that the actual physical damage the birds cause to the commercial flowers is scientifically negligible.
Yeah. But to combat the broader habitat loss, organizations like the Table Mountain Fund are actually directing resources toward clearing those invasive acacia species and expanding protected areas.
Which is great news. And currently, the population of the Cape sugarbird is estimated between 10,000 and 100,000 individuals, and it's officially considered stable.
But that stability is highly localized.
Right. Their survival is entirely dependent on preserving the specific Fynbos tracts they inhabit.
But because the population is stable, you actually have a fantastic opportunity to see this whole ecosystem in action.
You really do.
The sources highlight several highly reliable locations. If you're near Cape Town, the Kirstenbosch Botanical Garden and the Table Mountain National Park offer prime viewing.
And further inland, the Jonkershik Nature Reserve is heavily populated with them.
But if you're traveling the garden route, the local tourism guides pinpoint some very specific hotspots.
Yeah, the topography of the garden route creates these ideal little Fynbos pockets. Like up in the Otenica Mountains, just north of George, there's this small parking area near the summit of the pass known as Sputnik.
Oh, Sputnik, right.
The guides confirm that the pristine Fynbos surrounding that area, which is just thick with flowering proteus and ericus, is a major congregating point for the birds.
You also have the Nizhna Forest route, specifically the mature Fynbos lining the Guna Road. But the key to actually spotting a Cape sugarbird is to stop acting like a birdwatcher and start acting like a botanist.
That is the best advice you can give.
Right. If you just wander out looking for a brown bird flying against a blue sky, you are probably going to miss them. You have to locate the blooming protea bush first.
The flower is the primary resource, the territory, and the battleground. Find the blooming protea and the birds will just come to you.
It reinforces the reality that you can never truly isolate an animal from its environment. To observe the Cape sugarbird, you have to observe the Fynbos. Well, we have covered a massive amount of ground today. We've looked at the fluid dynamics of their capillary tongues, the evolutionary gamble of relying on a single plant family, and the staggering energy costs of those altitudinal migrations.
Not to mention the crazy unbraked flip jumps.
Yes. We've explored how they time their breeding for the brutal winter months, how the males leverage a 32-centimeter tail to broadcast their genetic dominance, and how the females engineer these insulated nests while dodging massive constrictors in the underbrush.
It really is a finely tuned, ancient relationship between the bird and the bloom.
It is.
But, looking at the modern data, it does leave us with an urgent mechanical question to think about.
What's that?
Well, we established that these birds are altitudinal migrants whose entire grueling winter breeding season is triggered by the blooming of the proteas.
Right.
But as global climate patterns become increasingly erratic, changing the frost cycles and rainfall periods, what happens if the proteas begin blooming a month earlier or a month later? If the ancient internal clock of the flower and the migratory instincts of the bird fall out of sync, how will this highly specialized gravity-defying relationship survive that gap?
That's a really heavy thought to carry on your next hike, but I hope it makes you look a little closer at the brush. Keep your eyes on the proteas next time you are navigating the Fynbos and watch for that unbraked flip jump. Thanks for joining us on this deep dive. See you next time.